We were using prime factorials, really large prime numbers, and factoring them as our way of doing encryption, because again, that produces problems where even a relatively simple one would require more processing to brute force hack it than all the computers we have for the rest of the universe running together. It just can't be done with classic computing. With quantum computing, it's really easy, and it's going to give you the result in about a second or two. It's not a magic wand, but for that particular example, it can crack it very easily. An example we often like to use with this would be if I put two cards on the table. I know what the two cards are, but I don't know which one's which. I only have to flip over one card to know what both cards are. If I put three cards out there, I have to flip over at least one card and maybe another to know what they all are. And by the time we have 100 cards out there, it becomes so difficult to know what each one is, and you have to do so many flips that it's going to, and this is a classic computing case, really bog down processing. A quantum computer only ever has to flip over one card in that example, and it knows what all of them are. I mean, it gets the right answer there. And that's going to screw with the prime factorial method of encryption, but there are many other ones we could use that would be safe against that. So you'd only be vulnerable to quantum encryption hacking if it was being done before anyone made that changeover. There are other methods we can use for encryption that are safer against quantum computing. And we will just have to start switching over those as these get better. And I suspect we will know well in advance when that time comes.